Hello everyone. We will continue talking about equations of equilibrium in 2D and 3D problems. And before we proceed, let's quiz and see if you have an element like this and we say the three equations, sum of forces of x, sum of forces of y, sum of moment equals 0. Are they the incorrect or the only correct or the most commonly used or not sufficient equations of equilibrium in 2D? The answer is C, the most common equations used. For this free body diagram, you will see that is it a single force, 2 force, 3 force, or 6 force. That body right here, since you have the forces, you have force right here and force right there, so you can have two forces applied on this element at A and B. But don't worry about it for now. What we really want to focus on is this example that I showed you before, and I said there is a cable, the own weight of the ramp, and the support reactions here. And also, if I give you an element, whatever shape you're having, and I give you the weight or the mass that you multiply by the gravitational acceleration, 9.81 meter per second square, you have the force applied here, and that is suspended by the chains. So you can find out the chains, maybe 1, 2, 3 chains, and so on, and you can draw the free body diagram and find the reactions. But keep in mind that some forces in x and y and moments are 0. I'm going back to the example that we covered before. If you have a cantilever free at the right end and fix it at the left end, the minute I see fixed support, I know I'm going to develop three unknowns in x, y, and moment. And the own weight of the beam at the center right here is given, and the load right here is given. How do I find the reactions? By sum of force of x, sum of force of y, sum of moment. So there are two types of questions that I'm going to ask. Either I'm going to ask, draw the free body diagram to show me the unknown reactions, or I say, draw the free body diagram and find the unknown reactions as well, and you find the values for that. So basically, this is what you do for this kind of example. For that example I showed last time, and I said, how many unknowns do we see? At A, I have two unknowns, right? And then the tension of the cable, since this is smooth, the tension here in the vertical cable, dB is the same as dE. So I have one unknown of tension and two unknowns at the supports. So I have three forces that I need to identify three unknown forces. If you have something like that, conceptual problem, like that kind of elbow, and that is subject to 800-pound foot couple and the force applied at this end, if we reverse the application, instead of this force pushing down, it's going up, and that moment right here, and instead of counterclockwise, it's clockwise. So what's going to happen? I believe the answer will be A. It will lift away from support A, or rather point A. If I have that kind of problem, that you do have that kind of crane, and the crane boom is supporting the heavy weight of a block, so the load here is 1,250 pounds, and we would like to see the boom is weighing 650 and the load of 1,250 pounds is suspended. We would like to know the unknowns. So what unknowns we talk about, or what free body diagram that we're having reactions? Here we go. At this joint A, you have a pin support AX and AY. The weight that we're talking about is 1,250, and the own weight of the boom itself at that point is 650. And since I see a cable, it gives me unknown reactions. So how many unknowns we have here? Three: tension and AX and AY. How can we find that? By the three equations of equilibrium. Another example that we talked about earlier, but we can repeat something similar to it. How can I draw a free body diagram for this? Two unknowns at D for the pin support. For the rocker bearing, I have only one unknown, and here I have one unknown perpendicular to A. Here we go. This is what we have. Fair enough? Move on to another example that we talked about. If I press here with a certain force that I don't know, I'd like to quantify it, And I developed the force in this link right here of 20 pounds, and I developed some sort of force in the spring, knowing the K of the spring and the stretch of 1.5 inches. I can identify the force in the spring. Here is the free body diagram. You find the force in the spring, you find the force, or given the force, in the bar. Then I would like to get the force F. Don't forget that you have a sort of a hinge or a pin right here that has AX and AY, and you would like to get the force here. So please practice knowing the free body diagram and know how can I find the force F. Hint, take the moment about A, find the force F. Other problems like that, how many unknowns I have here? One unknown at point B, right? And three unknowns at point A. So that is basically what we have. 1, 2, 3, 4. So 4 unknowns. 3 of them are forces and 1 couple. So the answer is D. Moving on. There is another thing that is very important. Any truss element or any rigid link, it doesn't have to be straight. It can have that kind of shape as well. Yet, we consider that a two-force member. What does that mean? If you make a cut and you see what forces are developed, it's going to be force at this pin and force at the other pin. They are collinear along a certain line right here. So I can replace this rigid connection, and we call it two-force member, by two forces. What applications do we have in real life? We have this kind of rigid link AB, that is one of them. This AB, the hydraulic jack right there, that can be simplified as two-force member. If you have a bracket like that, I can replace that with a force along this line. So I want you guys to know that there are two-force members, and you would like to know and to draw the free body diagram for it. Let me give you an application. If I have a cantilever, not a cantilever, rather a beam that's resting on a pin support at A and it's going to fall down. So to prevent that, we're providing a rigid link DE that is also supported at point D. How can we find out the support reactions at A and C? Basically, you don't want to panic here. Why am I saying that? Because I have 2 unknowns at A, 2 unknowns at D. That means I have 4 unknowns. However, I have only 3 equations of equilibrium. So life is tough and I cannot find it. However, there is a condition. The condition is that I have DE as a link. I can cut through it and I develop unknown reaction. And here we go. This is the unknown reaction in red color. And these are the 2 support reaction at A. Apply the sum of force of X, sum of forces of Y, sum of moment to find the unknowns. So we find out that sum of the moment will rent. If I take the moment about point A, I eliminate the effect of these 2 forces, and I only have the vertical component of force FC, which is FC sine of 45 degrees, times the 1.5, and that is positive since counterclockwise, and the 4 kilonewton multiplied by 3, which is clockwise, so it's negative, equals 0. You find out FC. Perfect. Once you found FC, you can do sum of forces of Y, sum of forces of X to find the 2 other unknowns, which is AX and AY. So this is very important for us to know, and I believe that this is good that you establish the free body diagram by making the cut and developing this. And the second step is to do the equations of equilibrium, and that's how you solve this kind of problem. You can have a problem like that in the test, which is a force applied at the end, or you can have a problem like this, which is basically you have a force and the moment as well. Same exact concept. You are gonna cut through this rigid link BC, develop a force right here, do the sum of forces in X, sum of force of Y, sum of moment, and you will be able to identify the force in the link. The only difference is we're gonna have a force and another force and the moment applied. So I urge you to practice doing that. That is very important and it's very nice. And if you'd like to get the final answers, FBC turned out to be 3.92, and also I can share with you that the AX is 3.13 pushing to the right, to the left, and AY, which is 0.95 as well, pushing downwards. So these are the free body diagram and equations of equilibrium that I would like you guys to be aware of and to find out how to get it. Some conceptual problems as well, if you wish. If in that case, which equation of equilibrium allow you to find F sub B right away? Is it sum of force of X, or sum of force of Y, or sum of moment, or none of the above? I believe the best option is to take the moment about point A, and that will give you the force in B. The second question, if you have that is supported on a pin support right there, and the roller support right here, and a pin support right there. So what the question is? The question is how many unknowns right there, and how many support reactions? We have 1, 2, and 3. So I have 3 unknown reactions right there. And is that stable or unstable? That is hard a little bit for you for now. At that point, we can discuss that later. It shouldn't be a problem, and we can discuss that later on, but focus on the top part and focus on the first part of the second question, which is how many unknowns we have here. That's all what I want you to do. So again, this is another review of the forces that you have on elements, and how can you identify the forces if you have a weight right here, a cable right here, another cable right there, and practice doing that. And I'm going to provide you with more lectures as well. I hope you like that. Thank you.